I'm here to share with you some exciting news. On the horizon is a new combined mRNA, flu, and COVID vaccine. This is great news because if this doesn't work, it is probably going to tank the Moderna shares, and we can't afford that to happen. The priority here is the technology, no matter who or how the science works. That's essentially what the hope is. And so people like me who ask questions are not considered very highly in the scientific perspective. And so what I'll be talking about today is this paper produced on the 7th of May 2025 about the immunogenicity and safety of influenza and COVID multi-component vaccine in adults over 50 years, a randomized clinical trial. We'll come to that in just a minute, but I will clarify now why I ask questions and why I think I at least should be given a little bit of consideration when I raise questions. And the reason is simple. I have a habit of being right. I say that as kindly and as gently as I can, because in 2020, I made the prediction about autoimmunity in COVID 19. This was actually our second paper. And you can see this is over 23,000 total views. We've had 56 citations. And at the time when we spoke about it, it made no sense. Now, it was just because we were looking at the science and we recognized that there were some unusual characteristics about COVID 19. Now, some people would have argued that, well, that's just a theory. Well, if they said that, they wouldn't have been keeping up to date with the science because, again, here in 2024, it technically confirmed exactly what we were predicting: autoantibodies to ACE2 associated with COVID 19 disease severity. So, when I'm talking about this, I am almost always coming from an autoimmune paradigm because it makes sense. And for me, when I approach the science that way, I'm able to make predictions that seem to do with the fact that I have some incredible strategy. No, I'm just simply extrapolating the question about autoimmune responses. That is literally all I do. Anybody can do it. It's not difficult. You just have to ask, what if? So, within that framework is the reason that I ask questions. Now, I said something that I don't think people understand what I mean. And if they do, they don't want to think about the implications of what I mean. And I said that there are some viral diseases that are not easily amenable to vaccines. And that's true. The most common one, or not common one, the most significant one that we can talk about is dengue. Dengue fever transmitted by a mosquito. But if you try and vaccinate against it, the problem with dengue is that there is immune imprinting. And so if you had one viral strain, if you get another viral strain, it causes an overreaction in the immune system, which leads to dengue hemorrhagic fever. And so the premise of dengue is that you have to be careful because the primary pathology is an overreaction of the immune system. That to me makes perfect sense, therefore, to be cautious with that kind of disease. And now, if you think about COVID, the reason you have severe COVID is because of an overreaction of the immune system. That's the cytokine storm. And so, for me, just simply from an autoimmune perspective, I would say therefore requires you to be very careful about how you interfere with the immune system. Simple as that. That's essentially what I've always said. If you're doing anything, make sure you consider those risks. What are the risks? What are the benefits? And don't just look in the short term because autoimmunity is a long term headache. It doesn't go away, and it causes problems years down the line. And so this is why I still speak about it. So let's get back to this paper, and I will highlight a few very important points that will be linked to something else I'll talk about in terms of just the immune responses and critically again, IgG4. But let's start off again with the paper. As you can see, this is supposed to be good news for Moderna, and they have to get this to work, because at the moment, if they don't get this to work, I think that is pretty serious from a financial point of view. And so there's a lot riding on this. And what they did is that it was a phase 3 study where they gave the mRNA 1083 and they found a non-inferior immune response against standard care immunization. So they were comparing the seasonal influenza vaccine co-administered with SARS-CoV-2, the Omicron XBB 1.5 vaccine. So they used these two together, and then they were measuring the immune responses. So you can see here that they had two age cohorts over 65, randomly assigned 1-to-1 to receive the vaccine plus placebo, or just the influenza vaccine and the standard COVID vaccine. And so they were comparing it head to head. And then what they were looking for was specifically humoral immune responses. That means antibody responses compared between the two. And they used about 8,015 participants, and they split the group in half, and they found in conclusion that it met non-inferiority criteria and induced higher immune responses than the recommended standard influenza vaccine and COVID vaccines against all influenza strains. So this is what they are now saying, is that this is a good thing, and they want this to move forward, probably to phase 4. The thing I don't like straight away is that if I click this full text, I need to pay for it. This is not accessible. And so what that means is straight away, they have a vaccine that they intend to use broadly in the population, and they are not freely sharing the data. That's a problem. How are they supposed to be challenged on it? Unless their intention is not to be challenged, which then would make perfect sense. But you have to, if you are doing something like this, I don't know if this is must be Moderna connected trial. What money do they need from the institution who is publishing this in order to get the public to be able to look at it? That's very, very important. So that's a red flag, in my view, is that this should be out there available for everybody to see. Now, one of the problems I have is the combination, because the flu vaccines have been around for a while. We know what they do. We know how they work. And they're relatively safe. You can argue about whether or not they work so well. That's a different argument, but they're relatively safe. But when you combine them, if you haven't fully explored the reason so many people got unusual side effects with COVID vaccines, that's a problem, because you will either, unless they assume that they're not going to have any further issues, I don't know why they would think that if they understood the autoimmune paradigm and the spike-mediated autoimmune responses, but then you will not be able to differentiate which one is the problem. So it will be either you pass over and just assume that the COVID vaccines are fine, or it kills the flu ones. It just doesn't make sense. They should never do this as a combination, especially with new technology. You start off on its own. If you're going to use mRNA technology with influenza vaccines on its own, 5 to 10 years, demonstrate that it works before you start fiddling around with combinations. Is that so difficult to understand? That's just my thought. Okay, so let's now get back to the basics of the science. And I'm going to take you through a few steps so to make sure you understand where I am when I'm talking about the technology and what it means. So let's start with some basic stuff. Here is a virus and the viral spike protein. It's cut in half so you can see inside. And on the surface are all these spikes. And this is what it uses to get inside a cell. You also have these orange, red and yellow points. These are envelope and membrane proteins. And then inside you have the RNA and you have the nucleocapsid proteins. And this is the spike protein blown up. This is what they use in the vaccine. And it's also, in my view, the most dangerous part of the virus. But then what is my opinion on it? So this is a starting point as to what we're doing or what has been done with regards to COVID vaccines. So in the context of mRNA technology, the basic premises are what needs to happen is that this is just a standard Moderna Pfizer vaccine. They take the mRNA, they place them in a lipid nanoparticle, and then this lipid nanoparticle protects the mRNA from being destroyed. It then gets into the cell and then it can replicate multiple spike proteins. In theory, this is supposed to be destroyed very quickly within a few days. I will not get into the arguments about whether or not that actually happens. Let's just say that it did, just for the sake of the science. Then what happens is a sequence of steps. The mRNA then goes into the cell, muscle cell, where it's been injected. It doesn't need to go into the nucleus. This would only happen with the adenovirus vector vaccines, but it makes the mRNA, it's released from the lipid nanoparticles. It then starts to produce spike protein. They are put on the surface of the cell. It triggers an immune response. The immune system comes and destroys the cell and then makes antibodies to the spike protein. And that's the premise of the science. And that's actually how it works. And so many people will argue and say that the COVID vaccines didn't work. And I'd say to them, no, actually, the problem is not that they didn't work, it's that they may have worked too well, in that the immune system could then become hyperreactive. But we know from the antibody levels that the vaccine works to produce antibodies. Now, there's another important part of this that has always been part of my concern and hasn't really been properly answered. But let's again presume that that question is irrelevant. But here is the fundamental premise with mRNA technology. Cells know that any kind of unusual RNA, especially if it's viral RNA, should not be allowed to make proteins. It's kind of like a check and balance inside the cell. And so they have these proteins that are there to pick them up, RIG1 and MDA5. And so in effect, when you produce these unusual RNAs, these proteins trigger the immune system to then stop this from producing spike protein or any other protein. In order for mRNA technology to work, it immediately has to bypass this immune response. As I've always said, that's a red flag. Anything that needs to stop the immune function of a cell in order to get the response you want, to me sounds as though you're going down a pathway that is likely to cause problems. But again, let's presume that's not the real question. So for the scientists, just in case they're listening, I'm sure the Moderna CEO is listening to me all the time. Here is the fundamental question that I think should be answered in that full text, or if not, in a follow-up paper, if you want to do the first stage of reassurance. So if you want to get past my questions, it's very, very simple. What we know is that mRNA triggers IgG4 responses. And I'm going to come to that in just a minute. But before I do that, I'm going to now show you an important piece of the puzzle with regards to what happens with immune responses on vaccination. So this is the two parts. One is just the immune response. That's another question that I want them to answer. The second part is about IgG4. So this was raised in 2023, where they were looking at what happens with the Omicron subvariant B2.86, BA2.86, and vaccination. Exactly the kind of questions that we had. And so this paper then, and I'll jump right down to where it's relevant, it looks at all the evasion strategies, but here is where it gets quite interesting. So they were looking at what happens with regards to the booster. So after they gave the booster, they were then looking at immune responses. And just in case you can't see it, I'm going to make it a little bit bigger. And just so that it's clear what exactly happens when you use the booster. When they gave the booster, you have at the bottom here a number, not all, a number of variants that they were looking at. This one here, WA1 2020, is the original Wuhan variant. Then they have the Omicron ones, BA1, BA2, BA5, XBB 1.5, XBB 1.1, and so going along. And what was very clear is that when they gave the booster vaccine, the highest response by far was to the Wuhan variant, 16,000. And so they make it look as though it's close. This is not close. This should be way up there. It's just because of the way how they use the BA1. And this vaccine that they used was a bivalent. So half of it was to this Wuhan variant. The other half was for the BA5 variant. And you can see this BA5 variant only went up to 603. The majority of the response by far was to this original Wuhan variant. That's a problem because these antibodies weren't working so well, which is why they were updating the vaccine. And so the first question that needs to be answered is, when they used this new vaccine, which is targeting the XBB 1.5, where was the primary antibody response? Do we still see immune imprinting, where the strongest response is largely to the Wuhan variant? Is it that there is now an equal spread of responses across multiple variants? That's what I suspect is going to happen, because there was a follow-up paper to this where they did, again, the same thing, looking at SARS-CoV-2 Omicron subvariant BA2.87.1. And this time, they were looking specifically at the XB 1.15 to see the response of the immune system to it. And again, you can see that here, even though the original Wuhan variant jumped twice, it was still relatively high, 3 times for the BA2. The highest was actually for the JN1, went up 13 times. Now, this wasn't the primary target, that and went up 5 times, but they are closely related, so it may not have been such a bad thing. But you can see that broadly, the immune system is still zoned in on that original variant. And so, as I said, this is part of the immune imprinting. That seems to be part of the problem why we're still having COVID circulating. The immune system can't quite recognize the variants. And every time they imprint another variant, you then have even more evasion. And you see the cycle going on and on. And this is tying in what Gert was talking about, where he's expecting there'll eventually come a variant that there is nothing that it can touch. What then happens next? That's part one, because I think that if they were doing that, they should have looked at which antibodies were targeting the specific variant that they vaccinated for. with the COVID variant. That is very, very important. So even though they said that they had non-inferior responses, my question is, did it actually respond appropriately, or is the immune system still confused? The second part of the question is now to do with IgG4. Now, I've spoken about this a number of times, but just in case you are not aware of what IgG4 is, your immune system produces multiple types of antibodies. And the antibodies are like missiles. They target things at a distance and help the immune system to then pick up whether viruses or bacteria or fungi or anything else, a toxin. The immune system uses antibodies. There are multiple types of antibodies. And you have IgM, which is early onset, IgD, IgG, IgA, IgE. For the purposes of what we're talking about, IgG is the long-term antibody that the body uses. But even that is split into 4 groups. You have IgG1 and IgG3, which trigger the immune system to go. They're like they're like the targeting. But you also have IgG4. I'll leave out IgG2 for the time being, but IgG4 does the opposite. It's similar to how the body is always doing that. It always has, if you have a strong action one way, it always has a balancing system. And IgG4 tells the immune system to back off. Don't worry, this is not a problem. This is what happens when beekeepers are continuously stung by bees. They have lots of IgG4 to tell the immune system, don't worry about the bee stings. So IgG4 does have a use and a place, but I wouldn't have thought it was particularly good in the context of vaccines. Why would you want that? This is nothing we have ever seen before. It doesn't even happen with the other COVID vaccines. This is something very unique to mRNA. So it's absolutely critical that this is looked at and clarified. And this is what it would tend to do, is that instead of triggering inflammation to the virus, it will tell the immune system to back off, to stand down. And so therefore you won't pick up the spike protein, and you're likely to have, in theory, more viral circulation across over time. And we saw this in terms of autopsies where there was significant viral dissemination. And a paper specifically looking at this IgG4, which is in yellow, this was from 2023, the class switch, you can see that if someone had mRNA and no infection, it's almost 46% of the antibodies that were produced were tolerant antibodies. This is not what you want. And so therefore, my question is, this antibody response that they said is non-inferior, what percentage targeted the variant that you wanted? And out of the total, what percentage were IgG4? We're talking about 40 to 60% of them being tolerant antibodies. What impact, if these are being produced, will it have on the flu vaccine? How do the two combine together? Will it dampen down the immune response as well to the flu vaccine? We have no idea. We've never seen or done anything like this. As far as I'm concerned, these are unnecessary kinds of gambles. Why would you combine it? Just do the mRNA. If you're going to do it, if you're going to drive it through and ignore all the questions, please at least do it on its own so that we can get 5 or 10-year studies, know it's okay. Then if you then had to combine them, do another 5 or 10-year set of studies, make sure it's okay. This kind of approach, to me, where they're combining them without that kind of research, is almost like you're trying to hide something, especially when you don't give us the paper. So my point now is, okay, let me extrapolate the science. So you're going to do it with me. And this is now where I'm thinking, okay, what are the implications long-term of this continuous production of IgG4? And you know what's interesting? Once the immune system has been primed in this way, even infection triggers IgG4. It's not just vaccination. And so there is ongoing IgG4 production. And I suspect, I've always suspected, this may be the primary reason why it had an impact on severe COVID, because it's a cytokine storm. It's like giving steroids. And so you dampen the immune response. And so therefore you have less of a severe COVID response. But it doesn't mean that people are not going to die. They will just die in different ways. So here is my extrapolation based on the primary targets that I think will be producing autoantibodies to specific proteins. There are three ones that I think are very important. The first one is ACE2. And the autoantibody effects will have an impact on the renin-angiotensin system. That's about blood pressure. So it will go off. So very often you're likely to then see blood pressure going off, kidney disease getting worse. You may get myocarditis, stroke, pulmonary disease, all from ACE2 autoimmunity. It may appear to be dampened because of IgG4, so it will not happen quickly. Neuropilin 1 is another protein that can be triggered with regards to the spike protein. And in this case, you get lots of neurology, neuropathy, chronic pain syndromes, dysautonomia, neuroinflammation. And the third one is CD147, which is on the surface of many immune cells, especially lymphocytes. And so if this is targeted by autoantibodies, you would get fibrosis in the lung and the liver. It could cause clotting issues and inflammation of the blood vessels. This is the kind of prediction based on an autoimmune paradigm that I would therefore expect to happen. So then, when would it happen? That's the problem, because autoimmunity never appears quickly. Autoimmunity is like a slow burn. It just hangs in the background and presents years down the line. And that's my concern, because when and if it presents down the line, nobody will remember why it occurred. Well, I probably will remember, but whether or not I'll be around to tell it is another thing. But here is now the likely prediction based on these premises in terms of time frames. 1 to 3 years, which is where we are, elevated IgG4. That's where we'll see the long COVID issues, multiple reinfections, latent reactivations of many viruses, Epstein-Barr, shingles, all of this will be happening. And there's not going to be much of a mortality shift. It will only be slight, which is where we are. When you look at the Office of National Statistics in the UK, it's not down, but it's not frighteningly up. 3 to 5 years, then you have the IgG4 is just dominant, being produced, triggered all the time. That's where you then have the chronic illnesses, reduced vaccine response. That's when the cancer signals go up because they're tied together. IgG4 suppresses the immune system, and the immune system is critical for cancer. And so you would then see a rise in cancers and chronic disease. 5 to 10 years down the line, by this time, the immune system is just flat. It's not responding. You're seeing early onset cancers, weak responses to new diseases, new infections. You're going to see rising cases, TB, measles, you'll have Campylobacter in India. It will just be all over the world. You're seeing these unusual diseases making a resurgence. And that's when you're going to see a noticeable increase in all-cause mortality. By that point, even if you know, what difference does it make? So many people will be so sick. So many people will be fighting with chronic illness. People would have died. And then you look back and you go, oh, yeah, that was a problem. It's kind of like what happens with asbestos. They knew asbestos was a problem from the 1950s. It wasn't banned until 1999. You know how many people ended up with lung disease because of it? That's the kind of approach we're doing now. And I suspect this is a financial approach, because when you do it that way, the implications financially are far easier to tolerate. We need more advocates. We need more people to ask questions, to push industry into answering the issues that are in front of us, not to just wave it away and keep on going. But this is a lonely journey. It seems as if very few people have any interest in these kind of implications. It's almost as if let's wait and see if it's a problem, we'll address it then. Well, the reality is, if that's what you do, you'll not be able to address it. You won't even be able to mitigate it. You will just be able to look at it. That's the reality. So, for those people who want to stay informed, remember, there are lots of courses. I have one here specifically because I think this is going to be very relevant, and I'm trying to figure out ways to be able to mitigate this. So, please, if you are interested, take a look at this. It gives you an overview and it ties you into the fact that I'm coming forward with a very detailed approach as to how we manage the immune system's response to this. I don't know what the answer is, but at the moment, it seems as though there's a very strong push to move on. Leave the past behind. Let's get on with the technology. The technology almost seems to be more important than people. You are in the way. If that's going to be okay for you, then don't ask any questions, but accept what comes in the future graciously. For those who don't, try and be educated. Listen, research, ask questions. Let's make sure it's not an easy ride. Have a great evening.